Hi, my name is Quinn. I'm a math professor at Broward College. In this video, we will discuss how to use your calculator to find values related to compound interest. Interest calculated only on principal is called simple interest. Interest calculated on principal plus any previously earned interest is called compound interest. The focus of this video is on calculating compound interest. With compound interest, after a certain period of time known as the compounding period, the interest earned so far is credited, or added, to the account, and the sum, principal plus interest, then earns interest during the next period. Interest is commonly credited to the account annually, which means one time per year. But it can also be credited to the account semi-annually, which is twice per year, quarterly, which is 4 times per year, monthly, which is 12 times per year, and even daily, which is 365 times per year. When interest is added to interest, which is added to interest, the result is exponential growth. This chart shows 3 different scenarios. In each case, $10,000 was invested at 5% interest. The blue line represents simple interest. Every year, the account earns a flat $500, which is 5% of the original $10,000. After 60 years, there are $40,000 in the account. By comparison, when the interest is compounded annually or monthly, the account grows to nearly $200,000 in 60 years. The formula that's used for calculating compound interest is A equals P times 1 plus R over M to the n power. Notice that this involves an exponent, which is why we see exponential growth. A is always the final amount in the account. P dollars are deposited as principal at an annual rate of R, compounded M times per year, and the money is left on deposit for a total of N compounding periods. N is always the product of the number of compounding periods per year, M, times the number of years, which are often referred to as T. In this formula, we have several operations: exponentiation, or raising to a power, multiplication, division, and addition. Operations must be worked with the correct order of priority, or we'll get the wrong answer. We always start inside the parentheses, brackets, or other grouping symbol. We apply exponents, then multiplication and division from left to right, then addition and subtraction from left to right. After we've done all these operations inside the parentheses, we work outside the parentheses. In this formula, we would need to work inside the parentheses first, starting with the division. Then we would work the addition, which would complete the operations inside the parentheses. Working outside the parentheses, we would need to apply the exponent first, and then we would need to multiply times P. For example, suppose we were asked to calculate the final amount in an account starting with an initial deposit of $8,560 at 4% compounded quarterly for 8 years. We should always start by writing down the formula. Then we'll identify each of the variables in the formula. We know that P is the principal or starting amount, which is $8,560. R is the interest rate, 4%, but we always need to write it in decimal form when we plug it into the formula. This would be 0.04. M is the number of compounding periods in a single year. Since the money is compounded quarterly, M is 4. N is the total number of compounding periods that will occur over the whole 8 years. 4 compounding periods for 8 years is 4 times 8 equals 32 total compounding periods. Plugging each value into the formula, we have 8,560 times the quantity 1 plus 0.04 over 4 raised to the 32nd power. Let's look at a couple of ways to enter this complicated expression into your calculator. This first approach breaks the procedure down into smaller parts. So, since we need to do the division inside the parentheses first, we'll divide 0.04 by 4, which equals 0.01. We need to add that to 1 to get the value 1.01 inside of our parentheses. This is what we need to raise to the power of 32. So we click x to the y to raise it to the exponent, and then we type in 32. equals, now we have the entire set of parentheses raised to the 32nd power, and all that's left to do is multiply by 8,560. And this gives us $11,769.49 if we round off to 2 decimal places or to the nearest cent. Let's look at another approach, which involves typing the entire expression into the calculator at one time. To do this successfully, we will need to place extra parentheses to let the calculator know which operations to do in which order. Starting with 8,560, we need to multiply this times the quantity in the parentheses, but also that raised to a power, so we need an extra set of parentheses. Inside the parentheses, we have 1 plus. Just to make sure that we do the division first, I'm even going to put the 0.04 divided by 4 in its own set of parentheses. Then I can close the parentheses for the sum, raise this set of parentheses to the power of 32, close those parentheses, and you see displayed the number inside that last set of parentheses. To perform the product, we hit equals, and we have $11,769.49 again. If you haven't done so already, now would be a good time to pause the video and make sure that you can perform these same steps on your own calculator. In the example we just saw, the original principal, $8,560, denoted P, can also be thought of as the present value. Our investment grew to have $11,769.49. We can refer to this as the future value or future amount, and that's always denoted A. Sometimes, instead of being told the present value, we'll be told the future value and asked to find the present value. To solve compound interest problems in which the present value is unknown, we'll use the present value formula, which is just the future value formula rearranged. For example, what amount must be deposited today at 5% compounded monthly so that it will be $18,000 in 20 years? When working a present value problem, it's always a good idea to take a moment to write out your formula. Then identify each of the variables. A, the final amount, is supposed to be $18,000. R, the interest rate, is 5%, which we must write in decimal form, 0.05. M is the number of compounding periods per year, which is 12 because the interest is compounded monthly. N is the total number of compounding periods over the whole 20 years, which is going to be 12 times 20 or 240. Plugging into the formula, we have 18,000 divided by the quantity 1 plus 0.05 over 12, all raised to the 240th power. Next, we'll enter the quantities into our calculator. We'll do this 2 different ways, but in both cases we'll make use of a fact of mathematics that you might have forgotten, which is that dividing by a number is the same as multiplying by its reciprocal. For example, dividing 10 by 2 is the same as multiplying 10 by 1 over 2. Either way, you get 5. We'll use this fact so we can take advantage of the reciprocal key on our calculators. First, let's try entering the formula into the calculator without the use of parentheses. Paying attention to our order of operations, we divide 0.05 by 12 inside the parentheses, equals, this value plus 1 is next, equals, now we have the entire value in the parenthesis, which we raise to the power of 240, which equals a denominator of 2.71 approximately. We're going to take 1 over that, the reciprocal, and multiply it by the numerator, 18,000. This just helps us not have to retype the value and avoid round-off errors. So we get $6,635.60. Now let's see if we can get the same result, $6,635.60, typing the expression in using some parentheses. Once again, I'm just going to type in the denominator and then multiply by the reciprocal of that. So we're going to have parentheses, we're going to have 1 plus, and just to make sure the calculator divides before adding, we're going to put parenthesis 0.05 divided by 12, close parenthesis. We need a second set of parentheses before we raise to the power 240. And we hit equals to get the value in the denominator. Now, instead of dividing 18,000 by that number, I'm going to hit 1 over x and multiply by its reciprocal, times 18,000. And this gives us a final answer of $6,635.60 again. Either way, the present value, or principal, turned out to be $6,635.60. Now it's your turn. Your challenge is to identify the expression that would result in the correct present value. Now the video will pause while you work out the solution. For best results, write your workout step by step on paper. When you're done, come back and select your answer. You chose option A. Let's check it out. Starting inside the parentheses, we're going to do the division before the addition. So we need to divide 0.06 by 12. Now we're going to add that value to 1, which gives us the quantity in the parentheses, so we need to raise that to the power of 120. So we have the denominator. We need to divide 5,000 by that, or in other words, multiply the reciprocal of that times 5,000. So we get $2,748.16. You are absolutely correct. Great job. As you continue to study, remember to use your resources. Read your ebook. Contact your professor when you need help. Ask your professor about tutoring on campus or online. Keep up the good work. You chose option B. Let's check it out. Plugging into our calculator, we need to observe order of operations. So inside the parentheses, we'll do the division by 4 first. Then we add 1 to that quantity. Hitting equals, this gives us what's in parentheses. And we need to raise that to the power of 120. That gives us our denominator. We're going to take the reciprocal of that and multiply it times 6,725. This gives us $2,743.38 to the nearest cent. This option is incorrect. Let's try another exercise. Here's a tip. Always wait until the operations have all been completed before you round off. Don't round off any intermediate steps. You chose option C. Let's check it out. We need to observe our order of operations starting with the division inside the parentheses. 0.07 divided by 52 equals, then add 1. When we hit equals, that gives us the quantity inside the parentheses, which needs to be raised to the 520th power. X to the y 520 equals gives us our denominator. We need to divide by that value or multiply by its reciprocal, which is what I'm going to do. So 1 over x gives us the reciprocal, and we multiply that times 6,500. This gives us $3,229.32. This option is incorrect. Let's try another exercise. Here's a tip. Wait until all the operations have been completed to round off. Don't round off any intermediate steps. Try this one. How much would need to be invested today at 3.5% interest compounded monthly for 18 years to meet the goal of $25,000 in a child's college fund. Now the video will pause while you work out the solution. For best results, write your workout step by step on paper. When you're done, come back and select your answer. You chose option B. Let's check it out. You've concluded that $13,327.01 should be invested at 3.5% interest for 18 years to result in a future value of $25,000. Let's use the future value formula to check. We'll plug in the present value, $13,327.01, the interest rate in decimal form, 0.035, M, which is the number of compounding periods in 1 year, which is 12 because the interest is compounded monthly, and N, which is 216. This means that A is $13,327.01 times the quantity 1 plus 0.035 over 12 raised to the 216th power. We'll evaluate this on a calculator. Remember not to round off any intermediate steps. By order of operations, we start inside the parentheses with the division first. 0.035 divided by 12 equals. Then we'll add 1 to it to get the value inside the parentheses. This number needs to be raised to the 216th power. Equals. Now we multiply this value times $13,327.01. And the result is $25,000. You are correct. Very good. As you continue to study, remember to use your resources. Read your ebook. Contact your professor when you need help. Ask your professor about tutoring on campus or online. Keep up the good work. You chose option C. Let's check it out. You concluded that $249.59 should be invested at 3.5% interest for 18 years to result in a future value of $25,000. Let's use the future value formula to check this out. We have a present value of $249.59. That would be P. The interest rate was 3.5%, so R is 0.035. The interest is compounded monthly, so M is 12 times per year. And the money is invested for 18 years, so the total number of compounding periods is 12 times 18, or 216 for N. We plug this into the formula, and we need to evaluate on a calculator. Remember not to round off intermediate steps. Observing the correct order of operations, we start inside the parentheses with the division. 0.035 divided by 12. We take that value and add 1 to it, and then we take that value and raise it to the 216th power. X to the y, 216, is equal to. This gives us the entire quantity raised to the power, which we now just need to multiply by 249.59. That results in a future value of $468.20, which is not $25,000. This option is incorrect. If you feel like you're struggling, that is part of the learning process. The important thing is to keep working and take advantage of all the resources available to you. Read your ebook in detail. After you read an example, try to work it yourself without looking at the solution. Contact your professor. Ask your professor about tutoring on campus or online. Then come back and try this item again. You chose option A. Let's check it out. You concluded that $23,723.17 should be invested at 3.5% interest for 18 years to result in a future value of $25,000. Let's use the future value formula to check. we have a present value of $23,723.17. That's P. Our interest rate is 3.5%, so R is 0.035. The interest is being compounded monthly, which means M is 12. And the total number of compounding periods over an 18-year period would be 12 times 18, so N is 216. This gives us A equals 23,723.17 times the quantity 1 plus 0.035 over 12, in parentheses, raised to the 216th power. Let's evaluate it on a calculator. Remember not to round off intermediate steps. Observing the proper order of operations, we need to look inside the parentheses and do the division first. 0.035 divided by 12 equals, and we need to add that value to 1, equals, gives us the value inside the parentheses, which we raise x to the y to the 216th power, equals, and now we multiply this times $23,723.17 equals $44,502.05, quite a bit more than $25,000. This option is incorrect. If you feel like you're struggling, that is part of the learning process. The important thing is to keep working and take advantage of all the resources available to you. Read your ebook in detail. After you read an example, try to work it yourself without looking at the solution. Contact your professor. Ask your professor about tutoring on campus or online. Then come back and try this item again.